Hello, the lesson you're about to observe is an instructional strategies model. We are covering a third grade standard under geometry and measurement. The students apply mathematical processes to determine and analyze attributes. The student expectation is to determine the area of rectangles with whole number side lengths known, using multiplication related to the number of rows times the number of unit squares in each row. The practices that you're going to see, the objective is for students to determine the area of a composite figure in relation to multiplication as rows and so many in each row. Oftentimes, we see in third grade, area is an abstract concept where students think that area is just a grid and they count the squares. Or area there's not a direct connection between the representations of multiplication, such as array, equal groups, repeated addition, and the area model. There's not a direct connection between finding the area of a garden or finding the area of a pool. And so we really see that disconnect of if an example is just the row and the column, one row and one column listed, the outside, they assume that it's perimeter, or their solution for area, they would to draw out the grid and to count. And so the differentiation is that I'm having students use area tiles using hundreds charts, and we're really focusing in on, one, how do we break down a composite figure? Two, how do we model that composite figure? How can we model that with the concrete and relate it to the abstract? And then therefore, how can we write multiplication equations related to the model that we see? My differentiation plan is that the process is being differentiated. I'm providing these students these manipulatives, these hands-on, these visuals, along with the abstract, what they might see, relating it back to the benchmark and how they're going to see it assessed in their consumable books or on short cycle assessments or tests. The product is, the group is differentiated based on this particular TEAC, and that there is some disconnect and some struggle with area. But as you notice that each student is on their different path and being able to solve using the area tiles. But the objective is they're able to demonstrate their learning in different ways, whether that be verbally, whether that be using the area tiles and communicating that. There still is that baseline understanding of the end goal, the end expectation is to have that multiplication equation represent the visual concrete model. I try to provide a differentiated learning style, with hands-on, with the abstract, with being able to manipulate. I wanted my students to make that connection, and so at this time I was able to say, okay, let's just sit down and think about it a different way. And so I'm trying to build being able to having, students who didn't master this the first time coming at it a different way. And so the expectations are slightly different. The content expectations and the concept expectation are quite somewhat separately if you look at the instructional lesson plan. But the objective is to be able to make that connection with area, find area, and then how do we move on from, the concrete representations of manipulatives to being able to do this with the abstract.